Good afternoon and welcome to Cyversity Engage webinar. Today's topic is hacking NFTs and beyond. Our Engage program is designed to grow, develop, and highlight careers, opportunities, and contributions of diverse talent within cybersecurity. Some of the topic areas discussed are career development, career spotlight, transitions, leadership, as well as technology talks. Our diversity highlights included in the Engage program. Some are listed here. For our agenda today, our Director of Membership, Christopher Cutts, will introduce our guest speaker. Following that, we'll have a presentation and QA session where you get to pose questions to the guest speaker. And following that, we'll provide you with some information on our membership benefits. As well, today we have a giveaway and we'll be announcing that and provide you with more information on upcoming Engage webinars. We invite you to communicate with us via our Slack channel, as well as email us at atlanta@cyversity.org. You can also find out more information about Cyversity on our website, social media outlets, LinkedIn, Twitter, and Facebook as well. A couple of things to know is that today's session is being recorded. And so if you need to go back and review today's session, it will be available later today on our website. And at the end of the session, you will be presented with a survey. We ask you to complete that to give us feedback on today's session. So now, without further ado, I'll turn it over to Christopher to introduce our guest speaker and continue on.
Thank you, Cassandra. Hello, everyone. Again, my name is Christopher Cutts. I'm the Director of Membership for Cyversity Atlanta, for the Atlanta chapter. So today we have our guest speaker, Jovonni Pharr, engineer, scientist, as well as founder of the Georgia Cyber Warfare Range. Jovonni, want to take it away for us?
Can you hear me?
Yes.
All right. Share my screen. Oh, it says you're sharing, so I think if you just stop sharing it, there we go. Right. Okay. Sharing. Let me know if you guys can see. Can you see? Should be good, I think.
Yes, we can see Jovonni.
Okay, awesome. All right. All right. So welcome. Thank you for the opportunity as always. Yeah, so like you said, my name is Jovonni. I'm one of the founders of the Georgia Cyber Warfare Range here in Atlanta. Okay. I'll get this out the way. So, all right. So from a high level perspective, what we say that we do, the range is a public data center purposed with hands-on technological training and education to solve challenging problems using advanced technology. So we actually have a facility here where we house a bunch of servers and we teach people hands-on things with those. So pretty fun stuff. So the problems that we're trying to really facilitate, though, we don't feel like people have access to resources that they need. We feel like that there's a huge gap in the labor market with respect to cybersecurity jobs. We also feel like businesses lack, access to localized cyber services, and that's where, we like to come in. But then fundamentally, too, there's no physical location for you to access in the Metro Atlanta area to do this type of work. So we solve that with a dedicated environment, and we also build a bunch of technologies, both open source and closed source, that we use to solve the problems that the technologies were made to solve. But then we also use those technologies that we built to teach people how to build the technologies, how they actually work, et cetera. And then we also give packages to kids and adults, depending if they want to do this work at home. So it's kind of high level. And this is the last slide just about us. So we have 8 different technologies that are in the world right now. 3 of them are open source. and open source being that the code is readily available for anyone to duplicate. And so, like I said, we use these tools to teach people how to do some cool stuff, high level. All right. So in the description, we make mention of the metaverse, and unfortunately today what we were going to do was we was going to do this whole talk in VR, but technical difficulties. But the point of that was going to be to show you that in the virtual world that I was going to be speaking from, everything in there can actually be an NFT. And so you guys might not be able to see this, but here we like to make this mention of who we think the first person in the metaverse was. And I don't know if anybody knows who this young lady is in these pictures, but she goes by the name of Sita. And she, and I'm sure some people in the audience who know who she is. She was a popular video DJ back in the day on BET, where but the cool thing about it was all of this was full motion capture and a bunch of editing too. But this is how the metaverse appears today. So we like to start with that joke. And we also make a delineation between the definitions of the metaverse. One being the concept of it and one being the marketing term. Because if you've noticed, at the end of the day, Facebook became Meta for a reason, right? They're trying to be synonymous with this idea of the metaverse. But people call it the new internet, but for the tech heads in the room, the metaverse is built on top of the internet, right? But we like to see it as a natural evolution of the internet with the focus on like immersion and personalization. And people don't know, but you can be in the metaverse without being in VR. So just keep that in mind. So my advice is try to separate the two terms between the concept of the metaverse and the marketing term. So just high level, companies are digitizing their stuff left and right, right? So, and there've been metaverses before Facebook been doing any of this stuff, right? Back in the day, they had something like Second Life, right? So, but nowadays you have all these different crypto metaverses, which is why we're here to talk about this stuff. And so in these crypto metaverses, one key primitive in these worlds is this notion of an NFT. That's where this land grab is happening. That's even items in the games, right? Depending on the different games. But you have to understand too, each of these are different games that may not talk to each other at all. And so I think that's super important to keep in mind. But we are very early in this time. So, but the point is that all of these items in these games or in these worlds can be NFTs if they're not already NFTs. But what in the world is an NFT? And I'm sure people have already heard this term, but in that acronym, this notion of fungibility is a key part. So I really want to explain what fungibility even really means. And so, in this graphic, you have this idea on the bottom left of you have a dollar bill, like $5 bill, right? If you have two $5 bills, they are interchangeable because they're the same. They're pretty much the same thing with different serial numbers, right? But the value of it is irrespective of the serial number. It's more about how much the dollar stands for, right? Or how much it represents. And so fungibility is about having some asset that's mutually interchangeable. Whereas something that's non-fungible is, let's say if you had two different baseball cards, one with Michael Jordan and one with LeBron James, they are two baseball cards, but they're not equivalent and they're not interchangeable. So keep that in mind, right? But when we talk about NFTs, one thing comes into mind that people may not understand. And first thing is this notion of an ERC. An ERC stands for an Ethereum request for comment. And an ERC is pretty much a proposal that a developer puts forth to say, hey, I want to propose this specific spec, and here's how it's supposed to work. And so ERC 721 is the specification that was proposed on Ethereum to define the non-fungible token. And so, fun little fact, one of the authors there, Dieter Shirley, I actually had the pleasure of having a nice conversation with him, and I love his work. He liked what we did with Kunta, so shout out to Dieter Shirley. But this is the actual specification of ERC 721, right? So if you're interested, you can go online and just look at the spec, but this spec is going to show you, so each specification, let me say this. So with the ERC, the reason why it's called a request for comment is because the developer puts it forth and they actually want other developers in the community to comment on it. And every blockchain has some methodology of this proposal like kind of setup. And so, but each specification, when the dev writes it, it comes with a list of it comes with a list of implementation details for that spec. And so for the NFT spec, this is telling you the exact functions that each NFT contract needs to invoke for it to adhere to the spec. But the thing you should keep in mind is that the NFTs, any specification is like a social contract. There is no ramification for not following it, because on these blockchains you have these notion of smart contracts, and smart contracts, you write them using code. And so there are some guidelines or best practices that devs put forward for you to follow. And so for the ERC 721, here's a list of the functions, right? So for example, you define here this transfer from function, which is a function you call to transfer a token from one person to another. One thing to point out here is some of these functions mutate the actual state of the blockchain and some don't. Right. So for example, if I wanted to call this owner of function, I could pass it a token ID. And remember, each NFT has a token ID specific to it that's unique. And I could pass this function a token ID and it will tell me which address owns it. Right. So one thing to keep in mind too is in Ethereum world, you have this notion of ERC20, which is another specification that defines the tokens. Right. But on those tokens, you also have a balance of function. But the balance of function for ERC20s gives you how much tokens you have, whereas the ERC 721 tells you how many tokens are owned by this address. So it's a little different, right? But the function signature is the same, right? So, but then you have more functions here on 721 spec. You have like, you want to check if a token is approved to be sent by someone, right? One thing people don't know is one of the implementations of the ERC 721 allows you to burn the tokens, and burning just means that you're sending it to, you're giving it ownership. Well, in ERC 20 world, burning is you're sending those tokens to the 0 address or some burn address. But in the ERC 721 spec, when you burn, you give it to the 0 address, but then you also remove the approval for the deployment address to send the token again, right? So there's a bunch of functions in the spec, but the interfaces, this is how you actually implement it. And remember, this whole talk is about how do you hack these things, right? So in order to hack something, you have to understand how it works first. Then you can see the rules of the system and then allow you to, do some cool stuff. But so there are different interfaces for the 721, right? So you have your core one, you have like metadata, you have a enumerable version where you can call certain functions that actually enumerate all of the tokens. You have a receiver version where it allows anyone who receives one of these, they have to implement some receiver logic, right? But then you also have extensions of the ERC 721. And this whole part is to show you that when someone says an NFT, first off, it means a token inside of a contract that is pretty much a holder or a manager of all these NFTs. But there's so many different types of NFTs that you can implement. So I think when you hear about the NFT word, just try to think about what type. So like here, this third bullet here, a lot of people think that NFTs inherently support royalties, but they don't. Like you actually have to implement an extension of that. So like on OpenSea is popular where if I sell an NFT and someone buys it from me, then I get a royalty on it, but that's not the typical, that's not the that's not the foundational NFT implementation, right? So then you have pausable, where if you can pause the contract to be where, you can't send any or transfer any NFTs or mint, etc. So, and all of this stuff is just defining the logic in the system, but all this stuff is customizable, right? And this is important. So another thing that I want you guys to understand too is with NFTs, the data isn't stored on chain. Of course, I can write an NFT where the data is stored on chain, but that comes with trade-offs. Typically, the data is stored in some decentralized location like IPFS or something like that, but it's not required because I can start an NFT right now using this specific logic. And what I can do is I can set my base token URI to be one of my domain names like Jovonni.com. And so I can make it where each NFT, the URL to get the metadata is Jovonni.com/token ID, right? So, and keep in mind, whenever you have an NFT, whenever you want to check the data, you don't check on chain, you get the token ID from on chain, but then you check the base URI to get where the data is located, right? So keep that in mind, right? So, but this is Solidity for those who really don't know, right? And the point of this is I'm showing the constructor here, where in this constructor, I'm setting up these different roles. I'm setting up the admin role, the mentor role, and the pauser role. So for these contracts, I can set up these different roles that allow different addresses to do different things. Like I can have a separate address that mints NFTs, but I can have another address that pauses the minting and another one that's an admin, right? So, et cetera, et cetera. And there's a project that just launched called Lens that actually is creating a whole social network where everything is an NFT. Your profile, your, posts, et cetera, et cetera. So, you can extend this because it's code, right? So, okay, and another thing, and some people who launched NFTs know what 1155 is, it's another specification because the common or the foundational NFT spec allows you to do one-off transfers, whereas this version, the 1155, allows you to transfer in bulk. So that's important, right? So for example, I can set approval for a bunch of NFTs, because keep in mind, if I own an NFT and I want a contract to transfer it for me on my behalf, I have to approve that contract address. And so with 1155, I can do that in batch. I can I can transfer in batch, right? I can get a balance in batch, so I can send in a bunch of addresses to get all of their balances as a return array, right? So this is another type of NFT spec, right? So just keep that in mind. So let's look at some issues in OpenSea. And some of the biggest hacks in OpenSea actually came from not hacking NFTs at all, which is interesting because one example is, and people calling this an inside job, who knows, but there were several phishing attempts in OpenSea. And this is actually one of the emails. So look how legit this email looks, right? He probably thought I was showing something from OpenSea. This is another example of this, right? And we know, because we're in cybersecurity, that phishing emails can sometimes be the downfall of an entire organization, right? So you can only imagine where this went. But the cool thing is, because of the way that OpenSea contracts were written, this picture here is showing you that in one single transaction, because this person had privileges, the right privileges, they were able to, because OpenSea contracts have some notion of administrative rights, they were able to transfer several different NFTs in one transaction. And that's not how the NFT spec works. The NFT spec allows you to transfer a single transaction per each, right? Unless you're doing 1155, right? But ERC 721 allows you to do one at a time. But you see, these are ERC 721 transactions or transfers all in one transaction, right? So that tells you that this hacker had elevated privileges, used the administrative rights, et cetera. And in here, what we're looking at is for the hackers or the people who want to be hackers in the room, in this space, you're going to have to get comfortable with looking at the traces of transactions, right? Every time a transaction is executed upon, if it's successful, you have logs that are associated with it. And those logs, you can see exactly what the call history is in the Solidity logic, which is awesome. But here, what I'm showing you is that this hacker pretty much traded different NFTs. Pretty much, that's what this is, instead of teaching you how to read this, right? But this screen right here is another view of what you just saw here, so keep that in mind. This is too, but you see they are, so this delegate proxy here, this is important. So this is the same exact attack, but what they did is what's the next slide? Okay, so what they did was when you're writing smart contracts, there are certain call types in Solidity, right? So I can make one contract can make a call to another contract, but in different ways. That's the important part. So if you see here towards the bottom, this says delegate proxy implementation. So this proxy pattern in the blockchain world means I deploy, because remember, when we deploy smart contracts, they are immutable, meaning I can't change the code. I can destroy the code though, but I can't change the code, right? So in the Solidity world, when I use a proxy, I set a smart contract up, and that smart contract, its only job is to route transactions to another smart contract. And therefore, that pattern allows me to upgrade my smart contracts effectively, because I can deploy a contract that points to one contract. And then when I want to upgrade one, I deploy another contract and then upgrade this proxy contract to point to the other one, right? So, but the way that the proxy contracts talk to these other contracts has some implications. So a typical call in Solidity is just this call, right? It's just this, it's literally called call. And I'm about to go over these call types. So the call, so in any smart contract, you have this notion of the context and its sender, right? So the context of a smart contract means the state that, because remember, each contract has a state in it, right? And at that address is there, or on the chain, there's just a state associated with what's going on with the address. But since every contract has a context, whatever context belongs to that contract, that is the state that contract can alter. And so if contract A makes a call to contract B, just a typical call, contract B, its context is itself, right? But the sender, once the call gets to contract B, the sender then becomes contract A. But then remember, contract A is what the original caller is calling. So the message sender the message sender when the execution reaches contract A is going to be the original sender of the transaction. But you see, once the execution gets to contract B, the sender changes and the context, right? So that's important. Whereas if I make this call type, what happens is the message sender never gets changed, even when the execution logic reaches contract B. And the context never gets changed. So effectively what this means is that contract B can alter the states of contract A. So that's important. But you know, this is typically not used anymore because it's so vulnerable. But this pattern right here, which is this delegate call, this pattern is used typically, and this is the pattern that this hacker exploited in the slides I just showed you. So in this context, when contract A makes a delegate call to contract B, the message sender is still contract A, right? Sorry, the message sender is still the external person, but the context is contract A. And so the way these proxy contracts work is the implementation contract that gets routed to from that parent contract, that implementation contract can alter the actual state of contract A. That is what that person was able to do, because in OpenSea, and I'll go over that in a minute, right? So and the last thing is the static call, right? And the static call, it's used, but not as often. But the only difference here is a static call is safer because it doesn't allow contract B to update state at all, which is important, right? And it's just a summary of the different call states. And like I said, call code is deprecated, but the delegate call is the one that's important here because that's relevant to what happened. So let me go back here. So if you remember, this delegate proxy was invoked, and when the way OpenSea works is I upload, actually have it here, right, just real quick so I can show you. Where's it? Oh, here it goes. All right, so on OpenSea, they're giving you tutorials on how to write your own ERC 721, because what you do is you write your own contract, you deploy it, and then you start interacting with your contract through OpenSea. But because I can write my own contract and deploy it, it can do whatever I want it to do. So I can have these functions already like implemented, but my functions may do something a little different than what's intended, which brings me to the next part of this talk, because there is an attack type, and it's a lightweight attack type, but it is an attack type called sleep minting. So everybody has heard about this person on the right side called Beeple. He made one of the biggest sales in NFT history, right, so far. But he had this project, and so what this hacker did, and you see at the bottom right there, it's called NFT theft. What this person did is they wrote a contract that implemented these functions, but in their Solidity, they allowed themselves to mint tokens for someone else, but then also transfer someone else's tokens as well. And so the way they did it, if you look at the call stack, remember, you can't change the message sender. Like once you send the message, that is always going to be you, because you're signing the transactions with your key or with your keys. But what you can do is this tokens transferred a variable here that's being shown, you can game that. And so what the person did is they made it look like Beeple was transferring this token because it was owned by Beeple, but their smart contract just allowed them to do that. But the vulnerability here is the fact that OpenSea allows you to just interact with your contract if you deploy it, right? So, and another thing that's interesting in this space is, and this actually is linked with fraud, it's this notion of wash trading. So with wash trading, you have this idea of, let's say, well, first off, let me explain it. So wash trading is, it's pretty much money laundering if you think of it that way. I have an NFT collection and I release it to the world. And then now, because I have $10,000 in my account, I'm gonna give $10,000 to that account and that account and that account. And then all three of those accounts are gonna buy my NFTs with the money I just sent them, therefore giving the money back to me, but then also making it look like my NFTs are selling, which creates more buzz around them, right? And so what this is showing is for different NFT sellers, it's showing the number of sales to self-finance addresses. And self-finance addresses is what I just said. Like I send that address to money and then it makes purchases for my NFTs. So this is an example of, you know, there's an NFT marketplace and then there's sales, right? But one of the addresses that's making the exchange or making the purchase, I funded it right before, right? So let's say if I send it 0.45 ETH and then it makes a purchase with 0.4 ETH, right? Like I'm funding that, right? So there are easy ways algorithmically to detect these things. So this is an example of the node in the middle of this graph is an account, and every edge on here is another address that was sent money from this main account. And so what this account did is it funded all these addresses, and some of those addresses funded other addresses, but then all of those addresses made purchases of this NFT. So you see, it's pretty easy to catch, but people are making a lot of money doing this today. Like these are very recent visualizations. So here's another type of asset in this world, right? So with refundable tokens, you combine this idea of the visibility facilitated by the ERC20, which is just a token. But then what you do is you make a contract and the contract owns the NFT, but then the contract actually issues ERC20 tokens to different holders. And if you have those ERC20 tokens, that represents fractional ownership of the NFT. So you see here, I'm defining what is what collateral, what asset do I expect people to buy this asset in? And then I'm also defining an NFT and I'm defining the share price, the share supply, et cetera. But then also I'm defining what me being an administrator. So here in my constructor, what I'm gonna do is I'm pretty much making an ERC 721, but then I'm also making an ERC 20. And then you see there at the bottom on line 17, I'm making myself as the administrator. And then here's my external functions, right? And really all I'm exposing is a way for people to purchase these shares. But then what I do is once they purchase the shares, I'm not sending them any NFTs. The contract still owning the NFT. I'm just sending them tokens, if that makes sense. So now when we talk about hacking this stuff, this is, and you have to keep this in mind, this is a public talk. So I can't show you how to, because doing this stuff, you could legitimately lay yourself in prison tomorrow, right? But for the people who really want to go down this path, what I want you to do is make note of these 4 tools. And I'm gonna show you how 2 of these work right now. So for the people in the audience who are security focused, how much time I have? Okay. In the security world, you have this idea of, let's say, okay, so let me back up. When you want to test the security of a system, right, you can do it in different ways depending on the system. But what we're talking about here essentially is reverse engineering an executable, because what you're doing is you're analyzing, you're statically analyzing code, but then you're dynamically analyzing an executable that's running, right? But when you're dynamically analyzing that, what you're doing is you're looking at the assembly level and up, right? So in the security world, before this whole crypto space, in the security world, you had this idea of fuzzing, you had this idea of symbolic execution, right? You had this idea of dynamic scans and static scans, and all of those things. If you have that background, your skill set is directly transferable to this space. So here's a few tools. One is called, the top left is called Manticore. I'll actually type that in the chat for you since it's not up here. So you can look them up now if you want. Manticore, this other one is Slither, other one is Myth, and this other one is Foundry. Look those up. Be careful with these tools. That's all I'm gonna tell you. You know, exercise responsible disclosure if you find anything interesting. But I'm gonna explain two things. So this notion of a fuzzer and this notion of symbolic execution. So a fuzzer from a high level perspective is if I write code, and let's say I have a bunch of functions in my code, I wanna be able to run some software that will run as many permutations of inputs to those functions as it can in order to find a bug. Like if I wrote a function that took a string, my fuzzer might send a string with different lengths at different times to see at what point does this function break if my string is too long. Or let's say if my string has, you know, mixed characters or something like that. Or if I send in an integer if instead of a string, right, my fuzzer will be able to automatically generate those inputs to my functions and try to break those functions, right? So that's what a fuzzer does. The other side, and that you can do that in different ways, right? But the other side of that is, because fuzzers are really good, but the other side of it is symbolic execution. And what symbolic execution does, which is why it's more powerful, is symbolic execution actually tries to construct mathematical expressions that define your software and then try to generate cases that generate cases that break the math. Think of it that way. They try to generate cases and prove contradictions in the code, or tries to generate cases that if you then took the equations that were generated on your software and then inputted these variables, that the whole thing would break, right? So it's still an exhaustive way of performing this type of security work, but symbolic execution, because it converts your software to mathematical expressions, is a lot more, it's a lot more reliable. It just takes a whole lot longer to run. So on my machine here, what I did is I just went on GitHub and got some random NFT project that some random developer threw out. And so I don't know if you guys can see, I'll make my font bigger here. So on the bottom here, what I'm doing is, I'll show you the command. So what I'm doing here is I'm running Myth, and I'm analyzing the NFT contract that's in this repo. And just to give you an idea what this looks like, it's literally just a contract that's instantiated ERC 721, ERC, the UI storage version. Remember I talked about those extensions, burnable and ownable is something else. Ownable just allows for like access control stuff. So you see how this has its only owner modifier here. That's what ownable allows you to do. But it has these very simple functions in there, a few functions, right? So what I do is I took this open source software, one of the ones that I listed on there, and let me close this. What I did is I ran it on this contract. And so if you see, what it returned for me is, it returned for me this potential vulnerability, but then it gave me this SWC ID. So, and also for the people in the room, if you want to, here, look up SWC registry. SWC registry. Okay, I'm gonna put this in the chat for you. Go. This right here is how you can see the different types of vulnerabilities that have been classified in, you know, in the Solidity world. And this is all Solidity stuff. But you see, it says 107, right? So let's look for 107. That's this right here. So, yeah, and so what it's telling me is that this function here, this free mint function, free mint is down here. This function right here, it's saying that it is potentially vulnerable to this specific vulnerability, right? And all I did was run one program, right? So be careful. And if we spent the hour just showing you how to do this, you know, you want to be careful. But another thing that I did is, so that way, let me go back. So that is this, that's MythX right here. The other program that I ran in another terminal window here is I ran Slither as well. And Slither, here's the command. All I'm doing is I'm calling it the executable, and I'm saying, here's my artifacts directory after I compile my smart contracts, and I'm asking you to run, this is a static analyzer, right? So, and for people who don't know, a static analyzer just doesn't run the code. It just looks at the actual code itself, semantically, syntactically, etc. And here what it does is it makes a reference to very well-known vulnerabilities that already have been documented, and it sniffs the code to see if anything is vulnerable there. And so the difference though is with this, because it's a static analyzer, it's more so guessing, doing guesswork to decide if this is vulnerable, right? So it's good to start with that. But this other one here, Myth, if this is saying that this is a vulnerability, it's most likely a vulnerability, right? And so and, this is a very simple thing, but here the output of it is it's telling me it's pretty much starting from some initial state, and it's creating this creator account, and it's giving it a certain balance, and then it's also creating this attacker account, and it's giving it a 0 balance. So then what it's doing is it's telling you, here's the transaction sequence that breaks this contract. It's saying the caller is creator, and now I'm creating this actual contract, and I'm setting that has a value associated with 0. But then the very next call down here, I'm actually calling this free mint function, and my transaction data is this whole hex string right here. And this whole hex string is literally the variables to the function that I'm calling. And then, and so you will have to take this and do some further analysis to kind of see how you replicate it. But it's telling you if you actually created these 2 contracts and called this right here with this input, that something not intended would happen, right? So, and this is the most simple version of doing this. But when you start having more complicated contracts, and mind you, this actually took probably like 4 hours to run, and I ran it overnight last night. But when you start doing this for bigger contracts, it starts taking sometimes like, a whole day, right? More than that. I think we had here at the range, because we run this stuff on our servers, here at the range, one time, I think this took like 7 days to finish on one contract, but it was because it has so many imports, right? So anyways, that's kind of like a high level overview of just those 2 different tools. But the takeaway from this is that you don't have to write the stuff yourself. You just have to learn how to use the different tools that are out there. And to be fair, the tools aren't perfect yet at all by any means, right? So down there, I think if I had to pick, I would say start off with all of these, because there's many other ones. But Foundry there at the bottom, it allows you to write your smart contract in this framework, but then also it allows you to, it has built-in fuzzing. And I didn't show you how fuzzers work yet, right? But at the end of the day, it's just doing a little less of what a symbolic execution engine is going to do, right? So anyways, I think that if you could take note of these different projects, it'll fast track you. But like I said before, be careful. And so, here's the motivation for everyone on the call, okay? Nobody's talking about this yet because people like me don't want to create more competition, but I like, helping our people out. So look, with these 4 tools that I just showed you, you can compete in these things. What you're looking at right here is a list of bug bounties. And I'm gonna actually put this in the chat. So it is Immunify.fi. Look that up. It is DeFi bug bounties, okay? There's like history has already shown several different developers, they'll spend 4 days on trying to hack a specific project, and they'll get millions of dollars like days later because they were able to do it, right? So, these people, you can do this stuff manually and use tools. I think that's the best way to do it, but nothing beats manually going through the repos, going through the Solidity and actually reading it. And I think that if you keep in mind the different things that we talked about today, about how the calls work specifically, right? I think learning how to read Solidity is going to help you. I think if you're specifically trying to target projects that have NFTs associated with it, I think understanding the types of NFT that they're implementing and what the trade-offs may be, I think that's going to be good. But there's not going to be any substitution for actually reading the code yourself. But these tools that I was just walking you through would help be supplemental. But at the end of the day, I just want to show you you could go out there and get one bug bounty on one of these projects one time and make $10 million. And there's so many people finding these bounties, but it just takes real thought and real engineering, know-how to do it. But it's not a superpower, right? I learned this stuff from scratch myself. So many others have. And I think if you are already in the room and you're an engineer, you already have a leg up. If you are in the room, you have an engineering background and you've already been doing like offensive work and trying to break executables and binaries, you're already ahead of the game. So just start orienting yourself to this space, right? But I just want to show you and this is an old picture. If you really want to see the type of money out there, just take a look at this and you'll see there's a whole bunch of money. And not to mention, you can go get a job right now as a security auditor just on Solidity code, like smart contract stuff, and make like $300K a year, easy remote. So, hey, I'm just a messenger, Okay, and that's pretty much it right there, right? I wanted to kind of show you that you can get started hacking this stuff today. Like I said, I just took that NFT project off GitHub and just literally found I found a few potential vulnerabilities in it, but then I also found some logic that's badly written, right? Just by using an open source project. So, sorry, was there I thought I heard a voice maybe?
No, I was saying thank you.
Oh yeah, for sure. And hopefully that wasn't too long, and hopefully you guys could walk away with something there. I'll take any questions if any.
Yeah, so at this time, I'm going to open up for the admin in the chat box, and we can answer your questions for you.
I can go back to any part of the presentation too if you want to see some stuff. Let me know. But
I have a question, Jovonni,
please.
real quickly. Have you made any money as a bug bounty?
I have made small amounts of money, not on Immunify yet.
Okay.
This is because
just curious.
Because crypto bug bounties have been out way before Immunify. But once Immunify came out, and Immunify came out like September last year. Once Immunify came out, the bug bounties went from, because typically they were like up to $100,000. That's if you found something crazy, like EOS had something like that one time. But I've won those type of bounties like on other platforms like BugCrowd, HackerOne, etc., but never Immunify bounty. However, and I'm just saying this publicly, us at the range, that is a part of what we're actively trying to do. And the cool thing about it is we're trying to teach people how to do it too, to help us do it, right? So that we can all try to do the same thing. But then also it's such a learning thing for people when they actually try to hack this stuff. So even if you try to hack these things, you never succeeded. Where you go from 0 to 100 during that time, you'll probably never be the same person again. You'll never look at security the same, right? But we actually built automated systems here to try to hack these things too. But it's super competitive. That's what I'm gonna say. You can imagine.
Hey, Jovonni, we got two questions. Shanisa asked, what type of training would you recommend as a part of the security auditor role you mentioned? Mm-hmm. Any resources you can point to auditing?
Yeah. So I think the first thing you want to do is you want to learn the hell out of Solidity, because Solidity is typically the language that these smart contracts are written in. It's not the only smart contract language though, but it has the most traction. So if you can master Solidity, and if you don't have a programming background, that might be a tall task, but it's not impossible. We have people now in the range who have never written a line of code and they're learning Solidity now, and it's not rocket science. It will help if you have a background in programming, but if you never have, you got to program at some point, right? So I think learning Solidity is super important. Like understanding these DeFi protocols, I think is super important. Like try to audit your own contracts, try to read contracts, try to participate in, I'll put something here in the chat. There's like these, look at this one. There's like these like capture the flag things that you can do. So, but there's a bunch of stuff, right? But I think there's no way around learning and trying to master Solidity. And I see people auditing right now who don't even have a mastery of Solidity. So, but I think aiming for mastery, I think would be really good, because you want to be good at what you do, so hopefully that helps.
Thank you, Jovonni. Ian mentioned, well, he's in the chat now. First question is the first step becoming proficient in Solidity programming?
Honestly, if you want to program in Solidity, I think, just any language. For anyone who wants to learn anything, I say start writing it as soon as possible, or start reading it as soon as possible. But, it's two different skill sets, in my opinion, knowing how to read a language and knowing how to write a language. Reading is a lot more easier. So I think anyone on this call can learn how to read Solidity today. right? And I would say definitely for people, the shameless plug, but I would say for people on the call who really want to go down this path, definitely sign up for the community pass at the range, because you will get the resources and talks about how to actually go down that path, and it's all like free. But I think, let's say if we never talked again, trying to master Solidity from YouTube and all of that stuff and books, everything, I think that'll go a long way, put like that. And I think that if you never programmed before, I think learning like JavaScript and Python would be good, especially Python, because you can write Solidity smart contracts in Python with Viper, which is it's just a way for you to, it's like bindings pretty much, but you can write your smart contract in Python essentially with Viper. But I think that learning Solidity is a really good exercise, honestly. It changes your mind a little bit if you program before, if that makes sense.
Nice. Ian also asked, can you name some prospective employers?
Yeah, I mean, yeah, you got Open Zeppelin, you got like Peck Shield, you got Certic, you got it's actually quite a few. And I think that if you're interested, I'll share my screen right now. I'll just do this really quick. If you're interested in this space, if you're interested in this space, you can go to like Indie Blockchain Security Auditor, right? And look at this, like, there's jobs for days on here, but like this is 179. Oh, this is director, right? Let me see. There's actually there's better ones for blockchain work. I forgot what sites they are, but if you just Google blockchain security auditor and kind of spend time going on that, you'll see. And I would say look on Glassdoor too, so you can see how much people are getting paid. But I'm biased because at the end of the day, if you just learned this stuff in the next couple months and you just spent your time on the side trying to win these bug bounties, all you need is one. And I'm telling you, it's not rocket science. And maybe what I should have done too is walk through, and maybe this could be a whole talk, Cyversity team, going through bugs that were already found and how they were found. And you can see it's really not rocket science, and it doesn't take infinity years, right? But talk is cheap. Once I win, or once the team wins $1 million, $10 million, well, you'll be the first to know. But a lot of people, you won't even know that they won these things because they don't want the public to know. They just win them and you'll never know where they are. But there's a vibrant community. I will also say join the Immunified Discord. Definitely join that, because that's where you got this ecosystem of hackers who are actively trying to break projects, probably for their own reasons too, but hopefully that helps. And so I see the other one here. It says, what sorts of jobs beyond cybersecurity auditor can we aspire to with these skills? Oh, that's amazing. So fundamentally, you could build your own blockchain itself, or your own blockchain application, and you could put. And the upside of that is, as far as you can take it, right? But at the end of the day, if you know Solidity really well, let's say if you don't want to do the security part and you don't want to like hack things or whatever, because Solidity, now you know how to program, and now you can build your own decentralized applications, your own DAOs, your own NFT marketplaces, your own tokens, right? Your own products. And I think that that's really if you have an entrepreneurial bone in your body, right? But I had to learn over time that not everybody has that. But I think that sky's the limit if you could learn these skills, right? But this is a talk on hacking NFTs, right? So I assume everybody in here may have some interest in doing something like that, right? But if you can hack NFTs, you can hack many other decentralized applications. So and you have opportunities on the job side and on the just making money side as well. And not to mention, if you know Solidity, you can write bots that then take advantage of the DeFi space. Because one thing I didn't talk about at all today is the opportunities in the DeFi space. For example, I can write a bot right now that takes out a loan of $10 million with zero collateral, 100% legally, and I can try to make an arbitrage play with that money all in one single transaction, if I can write the Solidity code to do that. And there's people, I'll have to show this really quick. I have to show this. This will be the last thing I show, because I can talk about this stuff all day if you haven't figured it out. So I want to show you, there's another company called Flashbots. Join their Discord too. So everything I'm about to show you right now is literally single transactions, right? So these are the ones that's happening today, right? So you got arbitrage opportunity here. They made $18. Arbitrage, they made $78, right? This person today made, and this is at 4:23, it's a few minutes ago. This person, arbitrage, made $277. But the magic comes from when you start looking at the most money made in a single transaction. The crazy part is this is a liquidation, and this person made $3.2 million and paid $10,000 in minor fees, and they probably took out a flash loan to do this, meaning that they didn't spend their own money to actually make the play. They probably took the flash loan out to do this, but all they paid was gas fees, if anything, to actually try the transaction, right? And you can check to see these because I can click on this link right here, which is going to open Etherscan, and I can go and look through exactly, what the contract did, right? So I can see here they spent 12,000 here, and that was probably by choice because they probably did like they probably paid the miner directly through the Coinbase or something like that. But the point is, you got arbitrage opportunities here, and this is people who made the most money. This is $1 million made in one single transaction. What I want to point out, one last thing here is, let's see. What's this next one? Okay, so this person made $780,000 and they paid $46. I could point this stuff out all day, right? My point is, if you do these skills, you could do bug bounties or try to make millions yourself. You could try to get a high-paying job at being a security auditor. You could start a company being your own security auditor. You can build your own products in the crypto world. That sky's the limit right there. But what you could also do is build bots that only try to do exactly what I'm showing you here and try to extract MEV, which stands for maximal extractable value. And that just means there's money being left on the table that if you wrote a good bot, you can extract that money. And so I just want to show you that the money here, if that motivates you, it's crazy. And all this stuff is legal. All this stuff, you're not hurting anybody, nothing like that. And so this isn't like the underworld or anything like that. So just really want to point that out. And I'll send you this link too, so you can look and marvel yourself, because trust me, I look at this stuff all the time. Look at that. And then I think we have one more question maybe. Can you share the link for that Discord? So this is for, if you just go to, I don't have it off top, but if you just go to, what was that? Not Flashbots, it was the other one. What was that talking about? I can send it if you can't find it. It was the other company I was pointing out. I can't remember. I talk about a lot. But yeah, I can probably send that to the group. It's not an issue. I'm sure it has something to do with what we just talked about. Oh, Mutify, there we go. Yeah, so I would say just go to mutify.com, and then they should have a Discord link on their page. Let's see. Yeah, no more questions. Yeah, if you guys have no more questions, I would just say thanks for the opportunity, and hopefully you guys learned something, man. Because like I said, I am just a messenger, but I try to show people that there's so much opportunity here that you had no idea existed. And this is why, we definitely, I think that they're going to share the recording from my understanding of how Cyversity works. But yeah, Chris, Cassandra, feel free to take it back. Thank you guys, I appreciate it.
Thank you again, Jovonni. At this time, we'll let Cassandra end with closing remarks.
Okay, thank you everyone so much for being here today. Jovonni, another exceptional presentation. Should I say Dr. Jovonni? This was awesome. Very technical, brought back some days of my software development, some of the terms you used, some of the code you showed. I really enjoyed it. And thinking about trying to become a bug bounty, make a little change there, huh?
Exactly. Yeah,
yes. Awesome stuff. Awesome stuff. Chris, thank you so much for moderating today's session. I greatly appreciate it. Again, Chris is our Director of Membership, And so with that, just going to share with you the mission of Cyversity. And I'm so grateful that you all attended today. And our mission is to achieve the consistent representation of women and underrepresented minorities in the cybersecurity space. We do this through programs that are designed to diversify, educate, and empower. Cyversity tackles the great cyber divide with scholarship opportunities, diverse workforce development, innovative outreach, as well as mentoring programs. Okay, Chris, do you want to talk a little bit about the membership benefits to our audience today before we close out?
Absolutely. Thank you, Cassandra. So yeah, why join Cyversity? We have several different initiatives to support your growth within cybersecurity, whether it's mentorship, whether it's directing your path with or guiding your path within cybersecurity, as well as training opportunities to support you as well. We're partnered with SANS, with Sarah, and a couple of other organizations to support your growth as well. We offer great opportunities, but more importantly, we're all about the community and all about instilling success within you. So hope you guys can join. I think our website should be available soon. Well, it should be posted within I posted it within the chat box. But to join our organization, students, it's $20. Professionally, would be $100. And that's the annual fee. But you gain so many resources once you join. You have access to all of our webinars, you have access to all of our leaders and also our members as well. You can join our Slack channel to communicate with us if you have any questions and concerns about this actual meeting today as well. We'll be able to support you through that process.
Thank you, Chris. And last screen here is just a wrap up of what Chris already mentioned. Someone asked earlier about if today's session is being recorded. It is, and you will be able to access that later on our website. If you search for on-demand resources. Also today, we have a training giveaway to attendees interested. It is an EC Council iLearning class that you have 1 year access to build your security skill set for ethical hacking essentials. If you wish to have access to this training, if you would, please email me at cassandra.dacus@cyversity.org. You can find this also on the Atlanta chapter webpage of Cyversity. You can find my email address there, and I'll be happy to provide a copy of the certificate to our attendees who are interested today. And I do have your names. So. All right, lastly, we would like to thank you for attending today. Jovonni, thank you again. And here are a few upcoming events, engaged webinars we're having later on this month on the 22nd with US Cyber Games, and then Impact Interview Series, which is a Saturday session interviewing various leaders within the cybersecurity space. If you're able to attend that, also do that as well. And lastly, please complete the survey that is presented to you today. I believe that our team members posted the link to in the chat session. So if you will, please complete the survey. And with that, we want to thank you again. Remember to stay safe and stay connected. Thank you everyone so much for attending today.